In this section, we'll be taking a look at the Configuring and Monitoring LDP Layer 2 Virtual Circuits objective of the JNCIP SP exam. For more detailed coverage of this topic, please check out the Juniper courses AJSPR, JL2V, and JL3V. In this video, we're going to take a look at the configuration and operation of Layer 2 virtual circuits that have been signaled using LDP. We turn to this network that's illustrated on the screen again, and it's exactly the same network that we used for BGP signaled Layer 2 VPNs. It's just in the service provider portion, we are now using LDP instead of BGP. We still have our full mesh of virtual connections between our three sites. And we're going to take a look at this network predominantly from the perspective of PER1. So let's do this now. Let's analyze some of the key configuration components firstly. So we obviously have protocols LDP configured for label advertisement, both the transport label forming LSPs between PE nodes and the inner VPN label, the inner service label that we're using to build our virtual circuits. We could be using RSVP for transport. However, to do that, we would need to tunnel LDP across RSVP, and that's beyond the scope of this video. So what you should note is that you have your standard interfaces, your PE and P-facing interfaces that we have LDP neighbor relationships formed over. We're also specifying the loopback interface and the protocol's LDP. And this is what enables us to form targeted LDP sessions to remote PE routers so that we can advertise our virtual circuit labels. So that's the LDP configuration. And then we have protocols L2 circuits configuration. This is where we actually configure our virtual circuits. This is different from the routing instance style configuration that you would use for BGP signaled layer 2 VPNs. So with layer 2 virtual circuits, we specify the neighboring PE devices on which the remote end of virtual circuits terminate. And then underneath the relevant PE, we map the local interface to a virtual circuit identifier. This needs to be unique network-wide, and it needs to be the same at both ends of the circuit. And we also configure things like the encapsulation. So in this case, we're using 802.1q Ethernet encapsulation for our emulated virtual circuit. We've got two virtual circuits, so this configuration is listed twice. This is the basic configuration that you need to get virtual circuits operating in an LDP signaled environment. Let's have a look at some of the operational commands that we can use to interrogate the network. So if we have a look at LDP neighbors, we've got our standard LDP neighbors there that we're using for LSP creation for transport label advertisement. And then we have our two targeted LDP sessions or extended discovery LDP sessions that are going to router 2 PE and router 6 PE. These neighbor relationships are resulting from this configuration. And over these targeted LDP sessions, we're advertising the information that's necessary to form our virtual circuits. Let's have a look at the information that we're advertising. If we issue the show LDP database layer 2 circuit command, we're basically looking at the information that's been advertised in FEC 128 TLVs. And we have label databases for every PE, incoming and outgoing. This is between ourselves and PE2. So we've received this label advertisement, and along with the label advertisement, we have some layer 2 circuit specific information, much like the information that was carried in the layer 2 signaling NLRI in the BGP environment. What we're saying here is that we are imposing control words on packets that are sent with this virtual connection. We are using Ethernet VLAN encapsulation on this virtual connection, and this virtual circuit is virtual circuit 1. We go down into the database further. We see the same information is replicated for PE-R6. It's exactly the same, although we're just talking about different label values associated with different virtual circuit values. So much like with BGP signaled layer 2 VPNs, we can now check the operational status of our virtual circuits. With the show L2 circuit connections, and the output looks much the same as the show L2 VPN connections output. So we have all of our virtual connections listed with their associated operational state and operational status. You can see that both of these virtual circuits are up and running, and we're seeing things like the incoming and outgoing label associated, the fact that we have negotiated a control word, and the encapsulation type. Much like with layer 2 VPNs, you can also issue the extensive command to see a history of those virtual circuits. And also, much like layer 2 VPNs, there's not a huge amount of data plane troubleshooting that we can perform. We can't be pinging from the PEs into the virtual circuit to test connectivity, that sort of thing. So what you would need to do is you would need to coordinate data plane testing with the owner of the CE device. We can just demonstrate the CE connectivity from one of our connected CEs now. So we're on XR1. On this CE here, we can test connectivity to Site 2 and Site 3. These are our interfaces to Site 2 and Site 3. We can see the IP addresses that we have configured on them. If we want to test to Site 2, we can ping across to Site 2. If we want to test to Site 3, we can ping across to Site 3. And you can, of course, do things like check the ARP cache, etc., to see the remote IP addresses bound to those interfaces. We left a ping running. You can see the interface counters increment on the PE side. This is a quick overview of layer 2 signaled virtual circuits configuration and operation.